to start and see if someone else joins. I am assuming you can all see the screen, the presentation, the PowerPoint. So
yes, we do.
Okay, thank you for confirmation. Yeah, of course, if you have any question during the presentation, you can just stop me and I will address any doubt or question, or we can leave those to the end. This is going to be a short webinar. It is prepared for maybe 30 minutes, more or less. There are like 20 slides in the presentation, so it won't take much time from you. And then, or in the middle, we will have the questions, but I guess that won't take us much longer. Right, so I think we can start. If someone else joins in the middle of the presentation, I will just admit them to the room. So, well, first of all, thank you everyone for joining this webinar. I am Professor Luis de la Torre. I am a teacher in UNED, that's the Spanish Open University. And this is the first of the bi-monthly webinars that we are organizing from the HELP project. I will introduce what the HELP project is in the next couple of slides. But first, I wanted to say that as the title suggests, this is a webinar that we are going to hold once every 2 months, approximately, and there will be 4 of these webinars, including this one. So, well, here is the contents of the presentation for today. First, as I already mentioned, we are going to make a brief introduction about what the HELP project is, to get the people in the room familiar with the context on this experience and why we are running it and where it comes from. And then we are moving to the experience in my university in UNED. And here we are going to basically introduce the master program or master course in which we decided to apply this engineering education experience with this help kit that we are going to introduce today. I will also introduce the subjects that we selected to apply this experience at, and reason and justify why we select these subjects. And the last part will be to actually present the practice that we did or carried out with this help kit in our university. So yeah, let's start with the introduction to the help project. So basically, this is a project with 24 months duration. It started on 2021, last year, on May, and it was supposed to end on April, but it is going to be extended for 3-4 months. So it will be ending maybe in June, July of 2023. This is an Erasmus Plus strategic partnerships project. So it has funding from the European Union. And basically the goal of this project is aligned with the call for these strategic partnerships that the European Union published in response of the COVID-19 situation. So the HELP aims to create partnerships for digital education, readiness in fields of higher education to face the challenges presented, by the shift that suddenly occurred with the pandemic. So there are 4 partners in this project involved. We have the Munster Technical University, Aalborg University. Well, sorry, the second one is actually Cluj-Napoca Technical University, Aalborg University, and then we have UNED, to which I belong. So the HELP project basically consists in 3 main areas or legs or aspects. The first one is developing a kit that is affordable and can be used in mostly electrical engineering education, but also some other practices. So the idea is to develop this kit, design it, decide which specifications it should meet, and so on. And then, of course, another of the legs is to use it, to put it into practice. That's what we're going to talk about today, about one of these experiences using this kit, in this case in UNED. The other 3 bi-monthly webinars will be for the experiences carried out in the other 3 partners. So we will have, in 2 months, we will have another webinar with the experience on Aalborg University, and then with Cluj-Napoca and with the last university. And the last important part of the project is the online community of practice. So basically, this is like an online space in which the partners are going to deploy and share all the materials that we are creating and all the experience we are having using these kits with our students in our universities. So basically, it is a space that any educator in engineering can go to and get the materials that we have developed and then decide if they are worthy or they can fit on their teaching and their classes. And of course, these 3 aspects are all related or connected. So for example, once the kit was designed and prepared and manufactured, we of course use it in the subjects with our students, and then from the feedback that we obtain and the experience on using it, we were able to redesign the board and the kit to add features or maybe modify some of its characteristics depending on the experience that we had using it. And as I said, of course, also the experience is going to be uploaded and shared to this online community of practice. So we're moving to the second part of the webinar, which is presenting the context on which the help kit was used, in this case in UNED University. So UNED runs a joint master with another university from Madrid called Complutense University of Madrid. And this master program accepts 30 new students per year. And one interesting thing about this master course is that we have a quite diverse background in the profile of our students. We have students that come from physics degrees, for industrial engineering, from electrical engineering or computer science. So they have quite different backgrounds, and of course this means that sometimes it is difficult to get a program that fits all their needs and allows them to follow the curricular in a nice way. So that's why there are several learning paths that students can choose from in this course. This is done to attend to this diversification. And for these, subjects are basically optative, but they are organized in modules, and students need to choose at least one subject from each module during the master program. So we decided that we were going to use the help kit in module 8 of this program, which is called practices or practicas in Spanish. So yeah, it was an obvious choice for us. We were going to use the help kit to make some laboratory practices. So this was the perfect subjects for us to apply it to. So we have 2 subjects in this module. One of them is called practices on instrumentation and control, and the other one is practices on computation and robotics. So I'm going to present the goals of the master and then the learning goals of the 2 subjects, just to give you the idea that the help kit actually matches these learning goals, and that it actually helped us to reach these teaching objectives that we have in our courses and in our subjects. So basically, the goal of the master program is to train specialists in the areas of control and systems engineering, and to make them capable of doing operations of maintenance, and supervision of automatic systems and control. So there are some specific competencies that we try to address in this course, and I just selected like 3 of them here that are reached or covered by the practice with the help kit. So those are those 3 that you can see there: control instrumentation analysis, knowledge about actuators, and knowledge about sensors. So these 3 specific competencies are a good match to be covered by the help kit experience that we carried out in the university. About the subjects, the 2 subjects in which we were applying it, well, we have also basic and general competencies, like those 2 there. The first one is know how to apply the knowledge acquired, and the ability to solve problems in new or little known environments. And the second one is develop creative thinking, critical reasoning, and ability to make decisions. So hopefully in a couple of slides, when I present the practice, this will fit on the objectives of the practice and the competencies of the subjects. So there are also specific competencies, of course, and a couple of them also related to the practice performed with the help kit is assemble control systems on real processes, including sensors, actuators, and so on, and identify all elements involved in a problem and coordinate them to achieve the correct solution. So let's move to present the help practice that we carried in UNED. Okay, so the idea of this practice is to characterize a DC servo motor and to characterize a distance sensor. So basically, students need to make the connections with the help kit and these components, this sensor and this actuator, in the breadboard. They need to gain solvency in handling an oscilloscope and a multimeter. And during the practice, they are going to learn about the details of how an actuator, in this case a servo motor, and a sensor, in this case a distance sensor, how they work. And as I said, the main objective is to characterize these 2 elements. So some additional considerations are that, well, UNED, as I said, is a distance education university. So the help kit, in our particular case, it allowed us to provide a hands-on practice to our distance students in an affordable way. The way that we did this is we prepared 1 kit for each student, and we sent this kit to the students so they could work and do the practice at their own homes. And this is important because in UNED we have students, well, the headquarters of the university are in Madrid, in the capital, but we have students spread all over the country. So what we did was to prepare these kits and send them to the students' home so they could work in the practice at their own homes, which is very convenient for them. Of course, working with the kit and with the circuit and so on, it has value on itself as students get some training on using and connecting things with their own hands. And this is also important in our university because normally what we do for laboratory practices is we use either simulations or virtual laboratories or remote laboratories. So laboratory equipment that is in our headquarters and that students can access remotely through the internet and operate through their computers. But the help kit gave us the chance to send them the real thing so they could work with their own hands on that. And of course, this kit also opens the door to perform some practices that are not possible to be performed remotely because even if you offer the option to make some practices remotely, not all laboratory practices can be operated in a remote way, right? So this opens the door to us to offer them new laboratory practices to be carried out during their studies. So as I said, the 2 subjects in this module 8 in which we applied the use of the help kit are these 2 laboratory practices subjects. As I mentioned, we have 30 students in the course every year, 30 new students in the course, but they need to choose either one of these 2 subjects on laboratory practices. So between the 2 subjects, we have 30 students with which we could test the help kit and this pilot experience. Unfortunately, as you may have heard, online and distance education programs and courses have a big drop rate. In our case also because our students are usually working and it is difficult for them to do to follow their studies and also keep on their jobs and so on. So we have like a drop rate of around 30%. And since these 2 subjects are running the second semester, the students who drop the program already have left by the time they start. So this means that normally we have around 20 active students between both subjects instead of 30. So instead of offering them the same laboratory practice as they could do remotely or virtually, what we did was to design a new laboratory practice that they could perform using this help kit. That's how we wanted to use the kit in our case. And we offer this experience to them as an optional practice that they could sign, like a pilot program that was optative. So we ran this experience last year in these 2 subjects of laboratory practices. And well, we had some logistic problems for receiving some of the components of the kit during the preparation of the project. And we only received 30 of the 20 oscilloscopes and multimeter called Hantex. That's the brand of the oscilloscope. So we could only send the kit to 13 students of the 20 that were initially planned during the project. We got 13 students signed for the pilot experience, but as it was optative, only 7 of them actually carried out the practice and delivered the work. And then we run the experience, or we are running the experience for a second year, and we are doing this right now in this semester, in the first semester of this academic course, and we are doing this in a different subject from the same master course, but in this case in the subject called sensors and actuators. So that's also an easy match for this laboratory practice. As I said, the objective is to characterize a sensor and an actuator. And this is still going on because, as I said, it is in this first semester, so it will end on February. So far, we got 12 students sign up for the pilot practice with this help kit. They have all been delivered to them. They have started working on that, but we do not know how many of the students will actually complete the work and deliver the practice report. So let's talk first about the help kit. So basically, the help kit consists on 2 elements. It is going to be reduced to just 1, but the way we were using it in the first year, there are basically 2 elements. First is the help board, and second is the Handtech. The Handtech is, as I mentioned, this component that includes a multimeter and an oscilloscope. It is a small device. We will see it in a picture. It is here. So it can be delivered to students' home easily or taken by them to home on their own if the context is a traditional university. And there is also a signal generator included in this Handtech, but we are not using the signal generator in our laboratory practice in this case. And regarding the help board, basically what we have is, well, we have 2 oscilloscope outputs here. We have the multimeter output, and we also have, the generator signal input and the multimeter output here. We have, of course, the protoboard in which you can or the students can make all the connections from the different electrical components, resistors, capacitors, the sensors, the actuators, whatever. The mini USB for powering the board. We have also 5 and 12 volts inputs for the different elements and the circuit. And also you have switches that you can connect through these connectors here and activate through the buttons there and so on. So the other elements that we used in our particular experience in UNED are a motor, the DC motor that the students need to characterize. In this case, it is the Futaba S3030 or 3003. It is a small motor. Dimensions are here, weight is here. So again, this is easy to transport or to send, and it is also very affordable. I think the motor is like maybe 3 euros or something like that each. Oh, and I forgot to mention about the cost or the price of these two elements. Well, basically the help kit is designed to also be affordable, around maybe 200 euros or something like that. We're also developing a new version that does not require the hand tech, and that will reduce the price, of course, but so far is in that range, more or less. And then we also have, oh, sorry, and I was talking about the DC motor. So it had to be modified for continuous rotation because it has a limit, and we needed the motor to move freely for this experience. And then we have the sensor. So some specifications of the sensor, and these are the things that the student need, or some of the things that the students need to characterize are the max range, which is 4 meters, the mean range, which is 2 centimeters, the measuring angle, and also the precision. Those are the things that the students need to characterize during the laboratory practice. So here are a couple of pictures of the students that they included in their laboratory reports when working with the help kit from their homes, and doing all the tasks that they were required to perform. So, well, the first thing is that the laboratory practice that we designed to use with the help kit was valid for the 3 subjects that we have mentioned, the 2 subjects about laboratory practices and the other subject for sensors and actuators. The lab activity basically required to use the hand tech both as a voltmeter and as an oscilloscope. The oscilloscope was needed for characterizing the distance sensor, and the voltmeter was used for the DC motor, basically to determine the gain and the time constant of the motor. And the lab activity basically required, to use the hand tech, as I said, to make all the connections in the breadboard of the help kit, as you can see here, for example, for the DC motor. You cannot see that much there in the case of characterizing the sensor, but the students also had to make all the connections there, of course. They also had to use the board switches to turn on and off for example, the input to the ultrasound sensor and do the measurements. They could also use the LED, but that was optional. And of course, they had to connect both the sensor and the actuator to characterize them. There were also 2 voltage dividers that you can see here in the breadboard that were needed to modify the input voltage to the DC motor, so they could adjust the input to the motor in order to make the characterization, in this case to measure the gain of the motor. So of course, one important thing about the project is also to get feedback from the students. So we prepared a survey, or we are preparing a survey that we are going to give to the students to get their their feedback on how the work was with the kit, and if they consider it useful, if they learned, if they found any difficulty, and so on. And this information is also useful to redesign the help kit, or modify the laboratory practice guide and the learning materials that we have prepared for them to follow the laboratory practice. But we have not given this survey to the students yet, because the second experience is being run right now, as I said, in this first semester. So once it ends, we will give the survey to the students and collect all the feedback, and hopefully we will publish that in somewhere. At least you will find the information in the community, in the online community of practice. And then we are designing a second laboratory practice that will be carried out in the second semester of this academic year, because the project contemplates the idea of performing at least 2 laboratory practices with the help kit in each of the university partners that are involved in the project. So the second laboratory practice that we are going to carry out is to make our students to create the circuit for an analog PID controller. And what they are going to control is the same DC motor that we have been using in the first practice. So this Futaba servo motor here is the one we are going to use to make the analog control with this PID controller that students will need to connect and create in the protoboard with the help kit.
Listen.
So yeah, that's the last part. That's still, as I said, something that we are going to do in the second semester. It's not yet ready, but we will prepare also the learning materials for that and share it, as I said, in the online community of practice. So you have the link for the online community of practice there. And we also have a website in ResearchGate for the project, in case you are interested and you want to follow it and get more information about the progress on the project. So thank you very much. As I said, this was going to take about half an hour. So I think we are on time. And if you have any questions or doubt or anything, of course, feel free to unmute yourself and talk.
Hi, Luis. This is Martin here. Sorry, I missed the start of the session because for some reason our internet dropped, so I missed 10 minutes. But thanks very much for the explanation. I hope that this is the first of many good use cases that illustrate what can be done, and hopefully others can see potential in it.
Yes, absolutely. So as I said, we will have the second webinar in about 2 months, more or less. I cannot remember, Martin, which university is supposed to present their use experience, but I think it's Aalborg or maybe Cluj-Napoca.
I think it may be Cluj, and then I think it may be us. It may be MTU in Cork.
So we will announce the webinar by the same means. And of course, they are going to present a completely different experience. We might get rid of the introduction about the help project, since we already did it in this first webinar, or maybe we will keep it because we may get new people attending the webinar and they need to get the context on the project, of course. But well, we will see. But what I want to say is that they will present a completely different case study.
Very good.
Well, any other question or anyone else want to jump in? If not, then I guess we can end this webinar. I want to thank you all again for attending, and hopefully see you in a couple of months for the second of these webinars. Thank you.
Thanks, Luis. Bye.